Okay, so what do we know in differentiation? We know in this chapter we are finding dy over dx. From what? This will be given in the question. Y equals something like ax to the power n. If anything is of this particular value, a multiply x to the power n. The power of x is n. Then it's dy over dx. The dy over dx of this equation will become what? A as it is. The power comes down and the power is reduced by 1. See, if the power of x was 3, then 3 will come down and the power of x will become 2. If the power of x is 5, 5 will come down in multiplication with a 5a x to the power 4. If the power was 5, so power will become 4. If power is 1, the power will become 0. If the power is 3, the power will become 2. The power is getting reduced by 1. 1 is smaller. This is how we find a dy over dx. I'll just show you one example for that. If y equals 5x square or 5x cube, for example, so dy over dx of that particular value will become what? 3 will come down, 5 as it is, 3 will come down, and the power of x is reduced by 1. 3 will become 2. And the dy over dx is now 15x square.
So I can't hear you.
You cannot hear me? Now, is it better?
Yeah.
Okay. So this is how we find dy over dx. Once we know finding the dy over dx, then I'm telling you there is application of finding dy over dx. Dy over dx is known as derivative of y. Okay, it is also represented by y dash or y prime. Okay, so y dash equals 15x square. Now I'll tell you one thing, that dy over dx, okay, it's a tool. Dy over dx, differential is a tool for what? For finding the slope. If you remember, in coordinate geometry we have seen slope, steepness. Slope tells us how steep is the line, how steep is the curve. For example, mountains are very steep, plains are less steep. So steepness. They're also known as gradient, represented by small m. We have already seen them in coordinate geometry. And this will be equal to what? Since I'm telling slope and dy over dx, they are same. The value of the slope now is 15x square. Okay, this is one thing. Then we have learned how to use this particular dy over dx concept for finding the equation of tangents, equation of normal. There are two kinds of line. Okay, there are two kinds of line. If this is my one line and I'm calling this line is tangent. If this line is tangent is drawn for any curve. Okay, if I'll draw a curve, so if this is my curve like this, so tangent to the blue curve is the black line. This black line is a tangent. This is for sure. Now I'm telling you one thing, a line which is perpendicular to the tangent is known as normal. This red line is normal because it is perpendicular at 90 degree. Perpendicular means the lines are intersecting, cutting each other at 90 degree. So the red line is now normal. The concept here is how to find the equation of this line, because normal is also a line, tangent is also a line. So how to find the equation of normal, how to find the equation of tangent? When equation of curve is given, curve is the blue line, okay, so blue line equation is given, or the point of contact is given, this particular point where the tangent okay, is made over the curve. This point is given. For example, hypothetically, I'm saying it's this point is 1 comma 2, and the equation of the curve is y equals 4x square plus 1. Okay, I'm asking you what is the equation of tangent. So equation of tangent, since tangent is a line and we already know what is the equation of a line, so the standard form of any equation of line is y minus y1 equals x minus x1 times slope of what? Slope of tangent, slope of the line. Okay, so what are the missing values in the standard form? This x1 and y1 value and this m value, slope of tangent. Do we know x1 and y1? Yes, this is the point of contact. x1 and y1 is any point lying on this line. Do we know any point of the line? Yeah, there are infinite points on this tangent line, but we only know a single point, 1 comma 2. So it is workable for us. Okay, we can just put this particular value in the question. So y1 value is 2, x1 value is 1. We still don't know what is the slope of tangent. Then I'm telling you, the slope of tangent is nothing but the slope of curve. Slope of curve, slope of tangent are equal. Slope of curve, I'm representing it by MC, is equal to the slope of tangent. We are finding the slope of tangent. So what is the slope of curve? Slope of curve, slope of anything is just the dy over dx of its equation equals mt. So what is dy over dx of the given equation of curve? So I have already told you, in finding dy over dx, you have to do it specific for a term. So 2 will come down and the power will reduce by 1. 2 will become 1. So the dy over dx, that I will call by MC, slope, will become 4 times 2, 8x plus differential of 1. Differential of any number constant is always 0. So the slope of the line is 8x. Dy over dx value is 8x. 8x equals slope of tangent. Okay, we need a number to put here. We don't know the value of x. Yes, we do know the value of x. To check it out, in the given equation, the point of contact was given 1 comma 2 and x value is exactly 1. We'll put 1 here, and hence the slope of tangent is now 8. And you got the equation of the tangent. Equation of tangent now is y minus 2 equals 8 times of x minus 1. This is the equation of tangent. Okay, what if the question is about finding the equation of normal? We have find the equation of this red line, this tangent line. What if the question is asking what is the equation of this normal? How will you do it? Same thing. Okay, we'll carry the question to this part. This will be the equation of the normal. Equation of normal. And this is not mt, so equation of normal, so mn. I'm writing it mn. So this time slope of curve will not be equal to slope of tangent. No. Okay, slope of curve will always be equal to slope of tangent, but we need to find the slope of normal, a different thing. How will you find it? So once you find the slope of tangent, there is a relation for finding the mn, because the product of the slope of normal and slope of tangent is always minus 1. They are perpendicular lines. See these two lines, normal and tangent line, they are cutting each other at 90 degree. For any such lines which cut each other at 90 degree, the product of their slope is minus 1 always. So I will use the analogy here. And the slope of tangent is already known. We have just find it out. It's 8. So the slope of normal is minus 1 upon 8. You got this? Everything else remains same. You just plug in the value here. Okay. Y minus 2 equals minus 1 upon 8. Not 8. Minus 1 upon 8 times x minus 1. This is how we find the equation of normal, equation of tangent. It's very easy. We just need to practice few questions on that. Okay, now starts a new thing. The newer thing in this lecture. Okay, what do we know till now? We know how to find dy over dx. From what? From the equation which is given to us. It is given to us. Given. From that we can find a dy over dx. Once you get dy over dx, that will be equal to the slope, m value. Then we have figured out how to find the equation of tangent and equation of normal. Now the next thing is double differential. Double differential. Okay, just we have, okay, in the same way we have found dy over dx, we will be finding that double differential, and then we will learn why do we need that, because dy over dx is required in finding what, in finding the equation of tangent, in finding dy over dx, in finding the slope, in finding the gradient. Why do we need double differential? What is first we shall know what is double differential. So if equation of y is given to us, let's say the equation of y is 14x cube, we can find dy over dx, single differential, and this will be what, 14 times 3 will come down and 3 will be 2. And now the final thing is okay, it's 42x square. That's it. This is the single differential, first derivative, value of slope 42x square for this equation. Now double differential is the same thing. Double differential is represented by this d2y over dx square. Okay, it's not dy square over x dx square, no, d2y over dx square. This is how we represent double differential, or you can write y dash dash, because dy over dx was single dash, single derivative was dy over dx, and hence y dash. Double derivative is d2y over dx square and y double dash. How will you find it? Same thing again, same formula from the derivative. Okay, for finding the double differential, you have to find the first differential first. From that, you have to follow the same step. 42 as it is, 2 will come down, and the power x will reduce by 1, and you will get 82x. Okay, for example, if the equation of y is 8x to the power 4, the question is asking find double differential. How will you do it? Same thing, first we will find single differential y dash, which will be 8 times 4 x to the power 3, and it will be 32x cube. Now double differential is asked, so y dash dash, again same formula, 32 times 3 y x square, x square. Okay, 32 times 3 x square, and the final thing is now 96x square. This is how we find the double differential. Okay, so see, now the question is, why do we need that? Why do we need a second derivative? Okay, this differential dy over dx is known as first derivative, or just derivative. Second differential d2y over dx square or y double dash is also known as second derivative or double differential, same thing, derivative or double differential. Okay, let's see one question on that first, finding a double differential. Okay, I want you to do it by yourself. Take your time. The first question is y equals x cube minus 5x square. The question is about finding the second derivative. You have to find d2y over dx square, or you can also write y double dash. It means the same thing. Y equals 6x square minus 4 upon x. Solve it by yourself and find the second derivative of the both equation of y. Again, in order to doing so, you have to find the first derivative first, y dash, and then from y dash you can find y double dash by using the same approach. Are you doing it?
Yeah.
Okay. See, you really have to practice such that for finding the first derivative and second derivative, you really don't require your pen and paper. Because every question is following the, I'm saying for solving the first derivative and second derivative, you should not be requiring pen and paper. You should be doing it verbally only. See, I can find it without using pen and paper because I have practiced enough of these questions. The first question says y equals x cube minus 5x square, right? So let's find the y dash first. Okay, let's take one term at a single time, x cube. So 3 will come down and it will become 3x square. X cube will become 3x square. 3 will come down and the power of 3 will be 2. That's it. Minus 5 as it is, 2 will come down. 5 times 2 is 10. 10x. Because power was 2, it has to be 1 this time. This was first derivative. Let's find second derivative, y double dash, which was the question. So 3 as it is, 2 will come down. 6x. Because the power of x was 2, it has to be 1 this time. Minus derivative of 10x is only 10. Because 10 remains as it is. Derivative of x is 1. 10 times 1 is 10. So 10 only. This is how you do the double derivative. For this question, y dash equals what? Let's rewrite this question first. Because we only know to do the differential thing for the value of x in numerator, not in denominator. So let's bring the number of the x value on the top. So it will be y equals 6x square minus 4x to the power minus 1. I have already told you, when you bring the value of x in numerator, the power becomes negative. If there was x square, then it will become x to the power negative 2. If it was 4 over x cube and you want to bring the x cube on the top, then it will become x to the power minus 3. Okay, it's fine. Now we can solve it. So let's find the y dash. 6x square. So 6 as it is, 2 will come down. 2 times of 6 is 12. The power of x remains x. It was 2 earlier. It has to be 2 minus 1. So only x. Minus 4 as it is. The power of x is minus 1, which will come down in multiplication. And the power of x will be reduced by 1. 1 was already there. Minus 1 again. Because we subtract power always. Here also we subtracted it. 2 minus 1. 2 was already there. We did the minus 1 here. So y dash equals 12x minus plus 4x to the power minus 2. We got this. But this is only single derivative. We have to find double derivative. Now again do it. Y double dash. 12 as it is. Derivative of x is 1. Plus 4 as it is. Minus 2 is in the power. Will come down. Minus 2. And the power of x will be minus 2 as it is already there. And we'll subtract it from 1. Minus 1. Then y double dash 12. 4 times of minus 2 is minus 8. X to the power minus 2 and 1. Minus 1 is minus 3. This is your answer. 12 minus 8 x to the power minus 3. Right? It's very easy. We just need to practice more questions. The more you will practice, you will be gaining your fluency in solving these questions. Now the question is, why do we need that? Ain't we sufficient with single derivative? Why do we need to do the double derivative? Why we need to do the differential twice? Because y dash is slope. Once you already know the slope, why do we need to find double derivative? Because y dash was representing something. It was representing slope gradient. What does y double dash represent? Why do we need that? This is the question now. And this is required in order to find at what value of x. See, if I will draw a curve here. Curve represent what? Curve represent the equation of y. Let's say the equation of y in this question was this one. 6x square minus 4x to the power minus 1. Let's say the same thing. 6x square minus 4x to the power minus. This is the equation. I will draw a hypothetical curve of the given equation. Let's say the curve is like this. This is the curve. Okay. Now if you notice that the curve, let's make it even simpler. So if you pay attention, your curve is making a turn somewhere. Right here. It has the maximum value. Now it's going down. The curve was highest at this point, whatever point it is. Okay, at this particular value of x value are represented on the x-axis somewhere here. This is the value of x. So this y double dash will tell you that the curve at this particular value of x, what is the nature of the curve? The curve is maximum or the curve is minimum. Okay, this is for what we will require to find a double derivative thing. Of single differentiation we call it. Okay. Double derivative, second derivative, double differential, they are all same. Single derivative, just derivative, single differential, just differential, they are all same. Okay. So this y double dash is required to find the stationary point and the nature of the curve. I'll just give you an example for that. How do we use this? Because now we already know how to find y double dash. Okay, we just have to apply the same formula on the first derivative, then second derivative will be found. Okay, once you know how to find second derivative, then we can form a question on that and we'll solve it using second derivative concept. And the question says, find the coordinates and the nature of the stationary points. The question is, find the coordinates and nature of stationary points of the curve. The curve is given y equals x cube minus 3x square minus 9x plus 5. The curve is given. The question is asking us find the coordinates, something in the form x comma y, and nature. Nature can be maximum, minimum, okay, at this particular coordinates that we will find. The curve is maximum, carrying its peak, or at the lowest, so is it minimum, okay, or inflection. This is what we will check. So what is the way of finding this? First, we will find the dy over dx of the given curve. Step number 1, finding the dy over dx. Find dy over dx. We'll do it. So x cube will become 3x square minus 3x square will become 6x minus 9x will become only 9, and 5 will become 0 because the derivative of a number is 0. Once we have figured it out, then compare the dy over dx that you have found with 0. Put dy over dx equals 0 and find the value of x. So when you will put it down, so it will become 3x square minus 6x minus 9 equals 0, because this is the value of dy over dx. Let's take 3 common. So x square minus x square minus 3x minus 2x minus 3, and 3 is common, and we'll go down to this side and become 0. 3 upon 0 upon 3 is 0. We got this. Now we need to solve this particular cost equation. And when you will do it, the value of x will be, factor of this particular quadratic equation will be x minus 3 and x plus 1 equals 0, and hence the value of x can be 2. Either the value of x is 3 or the value of x is minus 1. How did we reach here? By equating the dy over dx equals 0. Dy over dx equals 0, and then find the value of x. We have done the same thing. We found the dy over dx which is coming out to be a quadratic equation this time. We have compared it with the 0 and we have solved the values of x. We got this. Let's find the y values also at this particular point. Okay, so now these values of x you have to put in the given equation. The given equation was what? X cube y equals x cube minus 3x square minus 9x plus 5 minus 9x plus 5. We got this, and we have just found the values of x. This was the step number 1. What was the step number 1? Step number 1 was finding the dy over dx. You found it, then compare the dy over dx equals 0 right here. 3x square minus 6x minus 9 equals 0. Then solve the equation and find the values of x. We got 2 values of x. Okay, then put these values of x one by one in the given equation, not in the y dash, not in the dy over dx, not in this, no, but in the given equation. In the given equation, in this one, find y. So let's put 3 here this time. So if the value of y is 3, if the value of x is 3 this time, so y is 3 cube is 27, minus 27 again, minus 27 plus 5, and finally you are having y equals minus 2 minus 22. Let's put x equals minus 1 here. So y equals minus 1 cube is minus 1, and then minus 3, minus 9 minus 1 is plus 9 plus 5, and you will solve it. The value of y will be minus 4, and 9 plus 5 is 14. 14 minus 4 is 10. The value of y is 10. So we are having two coordinates this time. And the coordinates are, when the value of x was minus 1, so minus 1 comma 10, and from here it's 3 comma minus 2. Two values of points we are having here. Now we need to check if the curve is maximum here or minimum at this point. How will you check that? There we will require dy over dx, double derivative. So d2y over dx square, which is also known as y double dash. Let's find it out. So dy over dx was this. See this one. Let's find the double derivative, which will become 3x square will become 6x minus 6, and derivative of number 9 is 0. We got this here. Double derivative is already known. 6x minus 6. Okay, so 6x minus 6, we got this. This is the step number 3 when we found the double derivative. Now what? Let's one by one plug in the values of x. The values of x was 3 and minus 1. Let's put 3 first. So value of x is 3, double derivative is 6 times 3, 18 minus 6. 18 minus 6 is 12. Then the value of x is minus 1, double derivative equals 0, because okay, not 0, it's minus 6 minus 6, which is 12, minus 12, negative number. So we are getting two values of double derivative. So the conclusion is, if your double derivative value it's a positive number like plus 12, then, or if it's a negative number like minus 12, it can be 0 also. What information does it carry? It tells us that if double derivative is positive, this is your minimum value, minimum. That means when you will put x equals 3, so out of all the possibilities, infinite possibilities, x equals 3 will give you the minimum possible value of y always, because double derivative is positive. Okay, if double derivative is negative, then it will be telling us maximum possible value is known at this point. So if double derivative is negative, minus 12, at what value? When x equals minus 1. So at x equals minus 1, out of all the possibilities of x, the y value is maximum. Out of all the possibilities of values of x, infinite values of x, when x equals was 3, you will always get the y value minimum, the least value. This is how we solve them. Okay, we can also check it out. I'm telling you, at minus 1 it will always give you maximum value, at plus 3 it will give you minimum value. We have already found the values. See, at 3 the value of y is minus 22, at minus 1 the value of y is 10, and these are the maximum value. 10 is the maximum value. You will never get the value of the given equation greater than 10. Minus 22 is the minimum value. Okay, you can never get a value lesser than that for y. This is how we solve it. That means this point makes the minimum value is known at this point, maximum value is known at this point, second point. How did we know this? How did we solve this question? First of all, from the given equation of y, you will be find dy over dx, y dash. Once you know this, then compare your y dash with 0 and find the value of x. Find x. Okay, when you will find dy over dx, then put dy over dx equals 0 and find the value of x. You will get a value of x or more than 1. Okay, then you have to check if at x value the value of y will be minimum or maximum. Then you have to find the dy over this double derivative, d2y over dx square. And if this particular value is coming out to be positive, that means this is minimum value. If this d2y over dx square is coming negative, this is maximum. Okay, opposite is happening here. Negative value for maximum, positive value for minimum in double derivative. Okay, and we don't know if the point is maximum or minimum, so it will be the inconclusive case. We cannot conclude that. We don't know if it is minimum or minimum. If y double dash equals 0, because we have talked about positive or negative, it can be 0 also in some cases, so it's not concluded. We don't know about it. Okay, we have to use more advanced methods for that, for finding the maximum minimum, which is not in our syllabus. If y double dash is coming out to be positive for a certain value of x, then this value of x will give you always the minimum value. If y double dash is coming negative at a certain value of x, -1, so x equals -1 will always give you the maximum value of y. If double derivative is 0, then we cannot decide about the value of x. We don't know about the value of x. Alright. For example, y equals x cube plus x square plus 2x plus 1. This is the equation of y, we already know. Now the question is, find the maximum value and minimum value of y. This is the question, because then you will put any value, infinite values you are having for x. You can have infinite values of y also, right? That's what I'm saying. Out of the infinite values of y, I'm asking you, what is the maximum possible value of y? What is the minimum possible value of y? How will you find this? By using the double derivative concept. First of all, you require to find dy over dx, which will be this time x cube will become 3x square, x square will become 2x, 2x will become 2, 1 becomes 0. We got this. Now put dy over dx equals 0, and you will do it. So this whole thing will be equal to 0. 3x square plus 2x plus 2 equals 0. When you have done this, okay, you have to factorize this quadratic equation. The factors of this equation will be what? Okay, it's not possible to solve, but hypothetically you have solved the values of x. Let's say x is coming out to be this particular equation which we are having here is not solvable, because I have assumed a hypothetical question. This is why. But you will always have a certain solvable expression. You will solve it and you will get the value of x. For example, let's say after solving everything, you are having this x is 2x plus 2, okay, and 2x plus 2 equals 0 will give you what? -1. I have taken this completely hypothetical, -1. Now you have to decide at -1 x y value is minimum or maximum. How will you decide that? For that you need to find dy over dx. Again, that we call as d2y over dx square. Double derivative we have to do of the question. Single derivative of this, so double derivative we have to do the same formula on that, which will become 3x square will become 6x plus 2. Derivative of 2 is 0. That's it. 2x 6x plus 2. So 6x plus 2. When you will put the value of x -1, so it will be -6 plus 2, which is -4. And the value of double derivative is coming out to be negative this time. Negative value means maximum. That means if you will put x equals -1 in the question, the value of y will be maximum. Let's try this. When you will put -1 here, so -1 cube is -1, plus -1 square is +1, plus 2 times -1 is -2, plus 1. They are cancelled out and the final value is -1. So -1 is the maximum possible value of y. This is how we do this kind of question. If I again conclude the steps, then first, from the given equation of y, we find first derivative. Then we equate the first derivative to 0 and find the value of x. Find x. Once we get the value of x, then we again have to find double derivative from this, y double dash, and put the values of x that we have just found in this. And if y double dash is coming out to be positive, then this particular value of x which you have put and giving it positive value, this particular value of x is giving you minimum value always. If y double dash is coming out to be negative, this x value, when you will put the value of x in the given equation, given question, the value of y will be maximum. If it is coming out to be 0, then it is inconclusive case, not concluded. This is how we do it. This is how we find the maxima. Okay, maximum value is the value of y, minimum value is the value of y, but at whatever value your value of y is minimum, that value of x is known as minima. For example, in the earlier question we have seen, see in this question x equals 3 was giving you minimum value. This is why x equals 3 is known as minima. Minima is what? Which give you minimum value. Here x equals -1 was giving you maximum value. So this is maxima. Maxima is the point which gives us maximum value. Minima is the point or value of x which gives us minimum value. Minima for minimum, maxima for maximum. This is how we solve these kinds of questions. This is how we find maxima, minima, maximum value or minimum value, right?